Okay, welcome to this part. We are going to deal with a topic called refraction. It's a topic in Form 2. We are going to start with the line of symmetry. And the line of symmetry is a line that divides a plane figure into two identical parts. So consider the three figures which have been given. The first one, the line is already drawn, and we can see that this one has a vertical line of symmetry, and as it is shown there. Then consider the second one, and if you consider this, we are going to see that the line is drawn on that direction, and then this one is drawn horizontally. So the line of symmetry for the first one is called a vertical line of symmetry. The second one is an oblique line of symmetry, and this one is called a horizontal line of symmetry. So a line that divides a plane figure into two identical parts is called line of symmetry, and it's very important for us to know about that way. Now on to our next, we want to see how many lines of symmetry do the following figures have. And we have a square. A square can have 1, 2, 3, 4 lines of symmetry. Let's see what a rectangle will have. A rectangle can have only 2 lines of symmetry in that form. Then if you go to a polygon like a hexagon is a 6-sided figure, and we can be able to have them this way. 1, 2, 3, 4, 5, and 6 line of symmetry. An equilateral triangle has this line of symmetry, the line that can divide this one into 2 equal parts. And equilateral will have 3 lines of symmetry. Therefore, we can have more. Now, when you're having a circle, it's good to draw one, and then you draw also a scaling triangle to identify how many lines of symmetry you have. A circle, for example, there are so many lines that can pass through the center. So if you do that, you can try to see how many to have, and finally you'll see that a circle has infinite number of lines of symmetry. A scaling triangle has 0. Remember, a scaling triangle is a triangle that the sides are not equal. Then we move to reflections, and reflections are obtained when you draw the image that would be obtained in a mirror. So consider this, the word reflect, and then we have the mirror line along here. Then we'll have all the letters inverted on this side. So this is the object, we call this one object, and this one becomes our image. So let's consider how to get, or how we can relate these two. This is our object, and then this is our image. So if a mirror line is placed there, this is what will be formed. And I want us to identify some of the key points about reflection. One is that the two lines, the line from the mirror line to the object and the line from the mirror line to the image. So this one, if this is our object side, and this is our image, we are going to identify that this distance, if it's measured, then this distance would be equal to this distance. So we call them equal distance or equidistant. So, and then the two lines also, the two lines that form from the object and the image are perpendicular to the mirror line. So these angles at this point are 90 degrees. So the equidistant part and also the angle part is very important. So all angles between the mirror line and the image object line will give us 90 degrees. The next thing we are going to see is how now do we reflect objects on a mirror line. So consider that number. So since each is equidistant, we can get, or we are able to see that from this point, the number of units from this straight will be 2 units. So that will be the first point for this, and then we get the other one here. Then we come to this point and we can be able to extend this line on this side. So this point will give us this point here, and then this will go 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. We'll have the image at that point. Then you move to this. This is a point that is 1, 2, 3. 3 points on this side, so 3 points also on the other side of the mirror. Then we have the next point, which is 5 units. 1, 2, 3, 4, 5. Then we come to the last points here. These are 2 points from the mirror line. Also that way. Then if we join this one, this will be a straight line. Yeah, so this one becomes our image. One thing about, again, the object and the image, they are equal, only that the object is and the image are inverted. So equal in size and shape and even area. So on the next part, we are going to see what happens in a reflection on a Cartesian plane. And we are going to do a series of reflections so that you can be able to see how they happen. The first one is reflection on a Cartesian plane, and that is reflection along the x-axis. And the x-axis is a line called y is equals to 0. So this line is y is equals to 0. So I've taken a few points. For example, we have a point P, and point P is 3, 4. We are going to reflect along this. So our image will be formed on this lower part, on the opposite side of the mirror line. And this is 3 units from this, it's 4 units on the upper side of the line, so it will also be 4 units on this lower side. So, and our image will be, so P, which is 3, 4, we'll move to P. Then we normally put a point there, like we call it P prime. That is the notion of the image. This will be formed 4 units on the lower side. This will give us 3, negative 4. So this will be 3, negative 4. So we can try another one. We have Q, and Q is negative 2, negative 3. And since the mirror line is the x-axis, therefore it will be formed on the upper side of the line, and these are 3 units below the x-axis, so it will also be 3 units above the x-axis. So this point Q prime will give us negative 2, positive 3. So with this now, we can be able to see negative 2, negative 3. Then we have our image Q prime as negative 2, 3. So we can come up with a conclusion and say, given any point on the Cartesian plane and you are required to reflect on the x-axis, if you observe closely what is happening, if a point P is with coordinates AB, since we are rotated on the x-axis, the x-coordinate is not changing, so we have 3. It's the same line. X is 3, so this is 3, this is 3. So the x does not change. Then y is negative 2. The x is negative 2. It still remains to be negative 2. And this along this line is where the reflection happens. Therefore, if a point is AB, then we can conclude and say, if it's a reflection along the x-axis, therefore P prime will be A, because we have said the x-axis does not change. Then this one becomes negative B. So a reflection along the x-axis will give us a point PAB to P prime A, negative B, which is the case with 3, 4, we get 3, negative 4. And negative 2, negative 3, we get negative 2, then we have negative, negative 3, which gives us positive 3. So that is the first conclusion we are making when on a Cartesian plane, when a reflection is along the x-axis, then that is what we are going to have. 2, let's see a reflection on the line y is equals to, remember the y-axis, the x-axis was y is equals to 0 line. So we can also have this line on any other point. For example, now we have a reflection along the line y is equals to 1. So y is equals to 1. So what happens? We have said the distance is equal, so this is just 1 unit, so it will be, this point will be 5, 0, 5, 0. Then this one we have 1, 4. So we remove, this is 3 units from the line, so again 3 units on the line, this should still be 1, 1, negative 2. And the image for this one, negative 2, 2, 1 unit to the lower side, we are going to have negative 2, 0, which gives us the image of this. So what happens when the line is y is equals to a plus or minus b? So we can use calculation and come up with a conclusion in case this point is done. So consider a case, we have the x-axis, we have the x-axis, we have the y-axis, then our point P, which is AB, is here, which has been reflected along this line. We are calling it y is equals to h, and P prime, since our reflection happens along this line, along the x coordinates, the x will not change, so we'll have A, because P is on A as x coordinates, so P prime will also be A at the x coordinates. So we need y, and therefore this h is given by the distance from the x-axis to the line. For example, we had y is equals to 1, so h is 1. So if y is 4, h will be 4. If y is another number like 6, it will be y is equals to 6. So we get the distance. This is h. So the distance between these will be h minus b, the change in the y coordinates. The change in the y coordinates will be h minus b. And remember, b is the distance from the change in y from this point. So this is why we have b at this point. That's why we had a and b giving us that point. So this distance h minus b is equidistance. So the y coordinate will be equal to b, which is the initial for p, plus twice this distance. For us to get y, we are going to take b plus this distance, which is twice h minus b, or b plus h minus b plus h minus b will be able to get these y coordinates. If you work out that one, we are going to get b is plus 2h minus 2b, which will give us y is equals to 2h minus b. Therefore, any coordinate, or when we are having a point P, which is AB, now its image will be A, because you have said the x coordinate is not changing, then 2h minus b, where 2h minus b gives us the y coordinates, and h is the value that was given as the equation. Therefore, we can take a few cases here. So we have said the image for P with coordinates AB will be P prime with A 2h minus B. So with this, let's take a point like negative 2, 2. So our point P is negative 2, 2. So P prime by calculation will be negative 2. Then our h was 1. Our h is given as 1. So we are going to take 2 times 1, which is 2, minus b, and our b is 2. So P prime will be negative 2, 0, which we also found by drawing. I hope you can also take other points or any other equations on that line and come up with more. So that is when y is given as either 1, 2, or any other value, even if it is negative. So what is key here to know by calculation is that final statement that an object AB then will go to A 2h minus b. So we proceed with refraction along the y-axis, and y-axis is the equation of that y-axis is called x is equals to 0 line. X is equals to 0 line. This is that line. The line y-axis is also called x is equals to 0. We have said x-axis is y equals 0 line. So for us to reflect this one, so if P is going to be here, then the image of P will be formed on the opposite side of the y-axis, and this one will give us 2 units because this one must be uniform or equidistant. So this P prime here will be the coordinates here will be negative 2, and this will be 4. Negative 2, 4. So if we were to look for the other one which is Q here is 4, 3. So we move 4, negative 3. So we need to move to this side. So this is 4 units. So this is 2, this is 4. So we move around this line, and this one we are going to have q prime with coordinates -4, -3. So if you look at them carefully, we'll be able to see, and we can conclude that when reflecting on the y-axis, so a point P will be given by what? P prime, and the coordinates that will not change is the y, because we are reflecting along that line, along the y line. So the y coordinate is not changing, only the x coordinate is changing, and this is what is happening. We only need to negate a, and we are going to have the point as -a, b. So pick like -4, -3. Our a is -4. Therefore, when it goes to the other side, it becomes 4, and then y remains as -3. And then we have -2, 4. If we reflect along the y-axis, it will be 2. A will be positive now. Then y remains to be 4. So this one is an easier one. So let's see when it is along any other line along which is parallel to the y-axis, and this line we are calling it x is equals to plus or minus b. So for example, this point we are reflecting 0.64 along the x line, x is equals to 4. So this line will come straight to this part, and this p prime will give us this will be 2, 4. So we want to see whether we can be able to have a calculation for the same, and then come up with a conclusion of any other line that is parallel to the y-axis. So let's consider this. We have 2 points, A and B, point P with AB. So P is AB, P prime. What will happen along this line is that B will not change, therefore we are going to have B, and A is the one that is missing. We don't know what will happen to A. So this line is given as x is equals to h. So h is this distance from the line to the y-axis. So this one is the h, and therefore this distance is our interest, will be h minus a, which is also equidistant to this h minus a. So we need the x coordinate. So the x coordinate will be given by a, which is this distance, a, x is a here, plus twice h minus a, and therefore if we simplify this one, we get 2h minus 2a, and therefore x coordinate will be 2h minus a. So our point P prime therefore will be 2h minus a, then we have b. So if we can check this one, so we have already said that if our point P A B will be transformed or be reflected to P prime, which is 2h minus a b. So if we have our point, for example, 2, 4, we can check this. Even without drawing, we should be able to get the answer. So P prime will be 2h, and our x is 4. X is 4, so 2 times 4 will give us 8, minus 2, which will give us 8. 2 times 4 minus 2, this will give us the x coordinate, which is 6, and then our y still remains to be 4. So P prime will be 6, 4, and it's also possible you get this to this other side. So that's how we do a reflection when the line is parallel to the y-axis. These are the lines we call the x is equals to. So you can try out with other points to come up with the object and the image. So reflection in the line y is equals to x, and this is a line which goes equidistant between the axes this way from top right left downwards to the left, but it is equidistant. So when you're talking of 0, 0, 1, 1, 2, 2, 3, 3, that way. So we can see a point here. The point which I took was P42, and if it is reflected on the line y is equals to x, you see we have 2, 4, and this is a case where they just reverse. We are reversing. If this is AB, then we reverse to BA. That's why we have 2, 4. This becomes 4, 2. And if this is 4, 2, we have 2, 4. So reflect on the y is equals to x line is very easy. So you only need to reverse. Then we move to the next reflection in the line y is equals to negative x, and that's the line that we can also call y plus x is equals to 0. So if you look at a point like now, you took P as negative 3, 5. We also get now negative 5, 3. So what is happening here? So the negative x becomes positive y, and the positive 3, 5 becomes negative 5. And this is for y becomes the x coordinate but negative. So here, when we reflect along the line y is equals to negative x, we are going to have AB becoming negative B, negative A. So those few will show you how to reflect, and they will help you when you're drawing complete diagrams. As you're going to see in some of the examples, we can use this one and come up with the images of different objects using these rules. They make our work very easy. So as we conclude, we can look at this. This is a summary I've done that you can also use. When you have reflection on a Cartesian plane, so the first one we are saying along the x-axis, which we call y is equals to 0, a point, the object point which is AB becomes A negative B, and I've given you some points here to get the image. So here we can say A prime will be therefore B. We have said the object x remains, so this is negative 1, but B becomes negative, so this will be negative 2. So A prime will be negative 1, negative 2. B prime also negative 1, negative 3. And C prime will be negative, it will be 1, negative 2. So the x remain. Next we have along the line y is equals to plus or minus b, or the one we are talking of as h. So we can choose one. Let our line be y is equals to negative 2. So what happens? A remains, so we're going to have A prime. The coordinates, the object points we are going to use are the ones which are given there. So this will be negative 1. And then we are talking of y is equals to negative 2. So negative 2 is the one that you call h. So 2 times negative 2 give us negative 4 minus 2. So this will give us negative 4 minus 2, which will give us negative 6. So you can try the others for B and for C. So along y-axis, which we call x is equals to 0, then we have said here the point AB becomes negative A, B. So B is the one that is not changing. So A prime will therefore be, this will now be positive because it's negative 1. Then it will be positive, then negative B, which is 2. Then again we have along the line x is equals to B, and this one is the one we are calling h. So again, x is the one that is changing. You can pick any line and come up with your equations, with your image coordinates. Then along the line y is equals to x, that's where we are having AB becoming BA, then you can create the images. And finally we have y is equals to negative x. We have said AB becomes negative B, negative A, which you can easily use to get the image of those points. So as we will be getting other examples, we are going to see what is required and what can make our work very easy, so that we don't keep on constructing and taking a lot of time. This will really simplify our reflection work. So thank you for the time. I hope you have learned something. Like the video, you can share to others so that they can also watch, and we learn maths together easily.